Now the latest in European space robotics in Futuris. Just another humdrum day for the Scorpion on the surface of Mars. Minus 63 Celsius, an atmosphere of carbon dioxide. This 8-legged robot makes short work of the dunes, taking rock samples as it races, relatively speaking, at 1.2 kilometers per hour. About 60 sensors help Scorpion adapt automatically to different terrains, sending TV pictures back to Earth 70 million kilometers away. But at the moment, that's all science fiction. For now, Scorpion is just a prototype on test at a lab near Bremen in northern Germany. Researcher Dirk Spenneberg began working on it some 10 years ago. He's a firm believer in robots with legs, saying they give better mobility under difficult conditions than those with wheels. And the first results are promising.
We're now at
the point where these prototypes are being taken seriously for future space expeditions to explore deep craters. But I think we're only scratching the surface of the potential of these legged systems. If we can introduce a higher level of control and give the device more autonomy, we'll be able to interact with the environment much better. Actually, I expect that in 10 years we'll be able to cope with all kinds of terrain, climbing slopes and entering craters in really dangerous areas.
And that's
when we'll prove that legs are better than wheels or tracks.
The branch of science which deals with imitating nature is called biomimetics, and this robot's design has evolved from the walking patterns of real scorpions. Its 8 legs are driven by a complex network of 24 independent motors which articulate the joints. A plethora of cameras and sensors allow the robot to analyze its surroundings. Scorpion is one of the stars at DFKI, the German Research Center for Artificial Intelligence at the University of Bremen. 28 researchers and 15 students are developing robots of the future here. Cognitive robots, search and rescue robots, underwater robots, and of course, space robots. The director of DFKI, Frank Kirchner, is overseeing the latest version of Scorpion, which has 6 legs, able to take rock samples. He says research into space robotics is particularly demanding.
We have to ensure that all the materials we use aren't degraded and so lose stability when working in hostile environments like in a vacuum or under extremely strong radiation. And that applies to all the technology, not only all the cables, but the structural material as well.
This robot, Aramis, can operate autonomously in extreme and difficult environments, including the uneven and steep gorges and craters on Mars or the Moon. On its head, a camera so it can see where it's going. A laser scanner and 2 ultrasound sensors measure distance and help the device identify the kind of ground it's on, and then make the decision whether or not it's safe to go on or whether it needs to change course. Under the auspices of a European project called Hector, the centre is helping to adapt space robotics into technology for search and rescue teams.
Space robotics is a technology which drives development in other fields. The severe conditions in space mean we need to come up with very advanced electronics and hardware. Because it's so advanced, it's easily transferable to underwater or security applications. It needs a great deal of research and it costs a lot, but it has its advantages. Because these land-based systems have their roots in the stringent conditions of space research, they easily meet the tolerances expected of them.
Researchers and students here at the Politecnico de Torino are also chasing the goal of walking autonomous robots. The mechatronics department is currently developing this 10-wheeled articulated robot. But for years, the main aim here, like many other European research centres, has been to develop rigid-framed, multi-legged walking machines, which are considered the most effective way to carry heavy payloads over extremely rough terrain. Professor Giancarlo Genta is now on his third generation of space robots, after starting in 1997.
Here we have three prototypes. This is the first one, Walkie 6.1. It has 6 legs mounted on 2 rigid frames. As you can see, it's quite small, and it can deal with pretty steep conditions. After the success of this first prototype, we built a second one, a bit larger and more complex, powered by solar energy. This is a robot's electronic head. It has 2 TV cameras placed so they give a stereoscopic image. The onboard software then helps the robot to identify obstacles. This is the latest version. As you can see, it's still a work in progress, but it does function already.
Walkie 6.4 is already a semi-autonomous space robot. Each of its 6 feet can sense the ground below it. Its processors then decide if it can advance without losing stability. If it's too dangerous, the robot stops and asks human controllers for orders. The ultimate goal is to cut out that final part and enable the device to take the next step on its own. Robots like these, either on legs or on wheels, are essential for the exploration of Mars and the Moon. You need high-mobility machines to access difficult areas, like, for instance, volcanic lava tunnels. On Mars and the Moon, these tunnels could provide a vital low-cost human habitat, but the surface is very irregular inside, and to get in there and check them out, we need these high-mobility machines.
Però all'interno dei tubi di lava il terreno è molto accidentato e quindi ci vogliono delle macchine ad elevata mobilità.
The institutes in Bremen and Turin are planning to collaborate now to share their know-how and to speed up improvements in design. They both share a dream, to send a European designed and built walking robot into outer space within the next decade.